Welcome to our ArcGIS API for JavaScript tech session. This tech session is on options for consuming the API. And I'm going to kick things off. My name is Andy Gupp. I'm here with Tom Wason and Renee Rubalcava. We have a packed agenda for you. I'm going to be introducing the different module types that the JavaScript API uses. Renee is going to be talking about ES modules, and Tom will be talking about a special loader library that we use called Esri Loader. So there's lots of modules. Modules. What does all this module stuff mean? Well, to start things out, there's two different modules that the ArcGIS API for JavaScript provides functionality through. And those are ES modules, also called ECMAScript modules, or simply just ESM. And we also have AMD modules. These implement the asynchronous module definition format. So there's a variety of different ways to consume the JavaScript API. And we're going to help you make sense of all of that. We'll be covering the different types of modules, as I mentioned, along with the various methods and patterns for consuming them and the benefits and drawbacks of each approach. And the API's modules divide the functionality into logical subsets. Like you can see here, there's map and there's feature layer and widgets and many different classes. And it's the API's modules that help divide that functionality up so you can implement it easily within your application. So these two different types of modules are both available for local installations through Node Package Manager, or NPM, as well as on a content delivery network, or CDN. Both ESM and AMD are available through both of these types of installations. So let's peel back the hood on this just a little bit and talk about the construction of these modules. And oftentimes, many of us don't pay attention to what's going on underneath the hood. We just import the modules and use them within our application. Everything works great, and we can move forward with our development. But going forward, because we have different module types, it helps to understand how they work within the browser. So ESM, let's take that first. Let's say I have a test-esm.js file. And this is a really simple ES modules file. It just exports a height and a width property. And this is the syntax that we use. And then in my index.html file, I use the syntax import. In curly braces, I specify the height and the width properties, and then tell that import statement where to get those modules from, which is the path to my ES module. And that's it. That's natively interpreted by the browser. As you'll see below, AMD is considerably different underneath the hood. Here I have my test-amd.js file, and of course these are overly simplified examples just to make my point. This file contains a define method that returns an object with the height and the width properties. And even more differently, to consume this AMD module within my index.html file, I have to use a require method that within an array, I specify the module path, JS/test-amd. Then I give it an alias in the callback function. And within the scope of the callback function, then I can reference my properties. These are two different types of module construction, and the browser treats them completely differently. So where ESM is an official standardized module system that the browser naturally can interpret AMD, if you try and run this file, test-amd.js, in the browser, along with my index.html, you'll get errors that look exactly like this. The browser does not know what to do with require, does not know what to do with define, without the benefit of a third-party module loader like require.js or Dojo. They're just some examples of some third-party module loaders that have to load first to let the browser interpret what require and define mean. So that fundamentally changes the way that we use these two different module types. So let's look at it in a little bit more detail. Let's talk about ESM first. ESM is these are our newest modules. They've been around as beta since 4.18 in December of 2020, just last year. And they are available via NPM and CDN. And I have an asterisk on the CDN, which I'll emphasize in just a second. So ESM via NPM. This is our @ArcGIS/core modules. And the primary use case for our ESM NPM is for local builds, for using them with modern frameworks like React and Angular. Because it's a standardized module system and it works natively in modern browsers, it integrates well with most modern frameworks and build tools, including Webpack and Rollup. Now the ESM CDN, totally different. This is for testing and prototyping only. And you'll notice here that the import path for my map module is actually a URL. It's not referencing the node module's path for @ArcGIS core. It's referencing the cloud. And Renee is going to talk about this in more detail. It's just important right now at this point in the presentation to know that using our ESM CDN is for testing and prototyping only. So let's switch gears and talk about AMD modules. So the AMD modules use the pattern just like I was describing. Here I have an array that specifies I want a map and a map view, and then I give them an alias. And within my callback, I can use those within my application to initialize a map. So these modules and this pattern has been around since version 4.0, which was May 2016. It's been around a long time. The AMD modules are available as both CDN and NPM. The AMD CDN, which is implemented through this familiar script tag, is perfect for vanilla HTML and JavaScript applications. It's super easy to update. You simply increment the number for the version of the JavaScript API. The next time your users reload the application, they automatically get the updates. There's no installation necessary. It's minimal to no configuration depending on how you're building your application. And this CDN is highly optimized. We've had over 4.5 years to iteratively optimize how the modules are constructed, how the CDN is set for edge servers to cache static assets, for example. This is one of the fastest ways to get access to modules if you're building a vanilla HTML JavaScript application. As I've mentioned before, it does require a separate module loader. Now, oftentimes that's completely hidden from you. And if you're using a vanilla HTML application, you're probably never going to notice it's there. And you need to use this specialized library that I mentioned before called Esri Loader if you're integrating the AMD CDN with frameworks and build tools. And Tom is going to be covering that in just a little bit. Now, AMD for local installs. This build is called ArcGIS JS API or ArcGIS JS API. And note that the AMD NPM build is specifically for API versions which are less than or equal to 4.17. If you're building a newer application, starting at version 4.18 and later, then you should be looking at our ES modules. Now the AMD NPM, it works with Dojo 1 and Require.js. So if you're using those in your application, you have requirements to use those, then this is the right module type to be using in that application. It still requires a separate module loader, so there are extra steps to go through if you're integrating this into a framework that uses Webpack, such as React or Angular. If Webpack's under the hood, then you're going to have to use the ArcGIS Webpack plugin versions 4.17.x or earlier in order to make the AMD NPM build work within your build process. So let's recap. ESM works natively in the browser. Nothing special is required to consume an ES module within an application that's running in a modern browser. And AMD requires a separate module loader. And in most cases, you won't even know it's there, such as when we're talking about vanilla HTML JavaScript applications. But if you're working with frameworks, then the differences start to become a lot more noticeable because there's more configuration that you have to do. And AMD require and define methods aren't natively interpreted by the browser. And so with that, I'll go ahead and hand it off to Renee. Take it away, Renee. Thank you.
Okay, thanks, Andy. So yeah, I do want to talk about ESM today, particularly the ESM deployment of the JavaScript API. So ESM stands for ECMAScript module, which are the standard module system for JavaScript. It's taken us quite a while to get to this point. There have been a few other ways that you could load JavaScript in the browser, some back and forth and how that could work, but we finally come down to a standard way of doing it. The benefit here is that it has better support in modern build tooling, in particular things like Webpack and Rollup, because they can be tree shaken, meaning that any code that is not used for your application can be removed during the build process. Huge benefit. So getting started, how do I use the ESM build of the JavaScript API? You can just npm install at ArcGIS core, and you're ready to get going. This is going to be the ESM deployment for the JavaScript API going forward. So usage, how do you actually use it? It's going to look very similar to how you would have done it if you have up to this point been using something like Babel or TypeScript to build your applications with the JavaScript API, and then you're using the AMD build, and you had to maybe use the ArcGIS Webpack plugin for the AMD build, or you did some other little tricks to make it work. The only difference is that you replace the Esri path with at ArcGIS core. All the modules are in exactly the same place they were before. It's just going to be a different path that you have to consume them from. And the syntax is import module from module location. So if you're migrating from AMD or the CDN, like I said, you just replace the Esri folder path with the at ArcGIS core path, and you're good to go. So this is a quick and easy way that you can go ahead and migrate your application. If you're migrating from the CDN, which is an AMD build where we had to use an AMD loader to load the JavaScript, then you would remove the require function call and replace it with the import statements in your application. You can see how I've done that here. So npm and build tools. So some of the benefits you get doing it this way is that you can get a customized local build. And the total JavaScript you're going to load from the JavaScript API is going to be between 400 kilobytes to 2 megabytes. That is depending on the type of application you build, right? So if you're, especially if you're working with something like Geometry Engine, doing stuff like that, you're going to end up with a bigger footprint of JavaScript API that you're going to use. But if you're just displaying some maps and a couple of layers and doing a few things here and there, it's not going to be very big. 3D will get you about 2.5, maybe 3 megabytes, depending on how much 3D features you use. All right, so here I have a very basic Webpack application. It's already set up. It running over here on my page, and all it says is this is my project. Right? That's all I'm doing. Now assume maybe I want to add the JavaScript API to the project. Now for our purposes, we're going to go ahead and do it with a button. So let me do something like this. Let me remove this part. Let me make a button. Document create element. It's going to be a button, right? And this button's inner text is going to say open map. Bam. Okay. Now we're going to go ahead and append it to element. No, yeah, the element that I've got on the page. I save this. All right, I got my button. So what I want to do is when I click this button, I want to go ahead and display my map. So I'm going to, for our purposes here, I'm going to defer loading the JavaScript API on the application load, because there might be a reason that I don't need it, for example. So let's go ahead and work on that. So what I'm going to do here, first off, let me go ahead and create a, I want an item ID for feature layer, for example. So item ID is going to be equal to that. So that's an ID for a feature layer that I want to show. Let's go ahead and say that button.add event listener. Click. Actually, what I'm going to do, let's do something different here. Let's go like this. There's something I want to do here. We're doing a button click, but I'm going to create a function down here. I'm going to create an async function load map. Right? And this is going to go ahead and remove listener, because I'm going to add it, button.remove event listener, because we are going to be, good neighbors about it. We're going to remove the load map event listener when we do this. So there we go. So it's pretty basic logic, right? So it's going to load once and do something once. Okay, so now what I want to do is, because it's an async function, I'm going to import a map loader of some sort. Right, so how am I going to do that? Let me go ahead and add a new file here. We'll call it webmap.js. And first thing I need to do is I need to install the JavaScript API, right? So I'm going to go ahead and install ArcGIS Core. So let me go ahead and install npm at ArcGIS Core. I'm also, because it's a Webpack project, I'm also going to go ahead and install the ArcGIS Webpack plugin. So I get those two going. So now if I come over here into my Webpack config, and this has already been set up for me, I don't need to do anything weird here. I'm going to get my plugin, and it's going to be the ArcGIS Webpack plugin. I spell that right. Okay, now we'll come down to where the plugins are. Make a little bit more room here. And after the clean plugin, I'll go ahead and initiate it. And that's all I need to do here. All right, so that's pretty straightforward. Now in the index CSS, I need to import the CSS that's going to be used for this. Let's go ahead and import. And when you do an import with CSS, you can just a little, I think it's a tilde big character here. And that basically is going to tell Webpack that you want to look in the node modules folder to load the CSS file. Do assets, Esri, themes. We'll go with the dark theme. main.css. All right, so we want to bring in this web map file, right? So we're going to import ArcGIS map from ArcGIS core map. I'm also going to import my feature layer. So let's import feature layer from ArcGIS core layers feature layer. Now we can get down to business of actually building our map. Oh, geez, I need the map view. Can't display the map on the map view, right? So map view from ArcGIS core, use map view. Awesome. Okay, so let's go ahead and start building this out now. So const. Oh, we're going to export a function here. That's what I want to do. A init map. There we go. I like that. A init map. This is going to take an ID and a container. The ID is going to be for the feature layer, and container is going to be where the map should be displayed. So we're going to go ahead and create a feature layer. Const. Let's do layer equals new feature layer. And since I got an ID, I need a portal item and the ID. So let's go to create our map. So const map is going to be equal to new ArcGIS map. And here we're going to go ahead and let's get a base map with the dark gray with the A, right? I sometimes spell it wrong with an E. And then we'll add the layer that we just created in here, in the layers array, right? So it's actually a layers collection, but don't worry about it. Behave the same way. Now we'll create the map view. So const view is going to be equal to new map view. Okay, this is going to take our container, and it's going to take the map. And for our purposes, we're going to go ahead and wait for the view to finish doing its job. So we're going to say view.when, and in the view.when, this is a promise. So this callback will get called when the view is done. So it's actually venable. I could do .then, but I'm not going to. So now what I'm going to do, I'll make this an async function so I can get a little funky in here. We're going to go ahead and say that await layer when, and then we're going to go ahead and say that view.extent is equal to layer dot full extent. So we're going to zoom our map to the layer itself. All right, so everything's starting up, compiled successfully. Still got my button here to open a map. So what I want to do now is that I'm going to do a dynamic import. So I'm going to say that const, and because it's a named export out of here, init map is going to be equal to await import web map. All right. So now what I'm going to do is I'm going to go and remove this button. So lm.remove child button. Yeah. And now I can go ahead and say that the init map is expecting an ID. So I'm going to pass the item ID. I'm going to pass the element as a container. And if I did this right, I should get a map here when I click the button. And yeah, there we go. That's how I'm able to go ahead and dynamically load that module in there. So this is how you can very simply, well, I guess simple is a relative term, but a workflow where you can go ahead and add the ArcGIS JavaScript API to a current project, in particular if you're using Webpack. So all I had to do was install the ArcGIS core, so that's the module for displaying the maps and everything, and I installed the Webpack plugin just as a convenience because realistically, let me save this here. Realistically, all the Webpack plugin is going to do is it's going to manage copying of my assets over, because that is the one thing that you do need to do. If I look at Node Modules ArcGIS Core, there is a folder in here called Assets, and it's the Assets folder. It's going to have things like the worker files, fonts, styles. It has a JSON for all of the translations in the API. So those are just kind of static assets that need to be copied over when you do your build. So you could manually do it yourself if you wanted to, but the plugin is just a little convenience to help take care of that for you. Like I said, the ArcGIS Webpack plugin is just a convenience to be able to handle copying all those assets for you. You could do a very similar integration using something like Rollup. It would be the same thing. You just have to manually copy those assets folder. But what's neat here, and let's look at the network traffic here. And what's interesting here is the fact that when you do these dynamic imports like this, and I'm going to dynamically import it here, this dynamic import actually gets converted into a chunk in the API. So when I start my application, I've got one JavaScript file, and this is dev mode, so they're a little larger than what you would get in the build, production build. So I've got one JavaScript file is loaded when the page loads, but then at some point during the workflow of a user using my web page, they might trigger something that's going to open a map. In my case, I'll trigger a button click, and that's going to go ahead and load all the modules needed to load the map and loads any other JavaScript I need. It's a pretty good workflow to use because the JavaScript API, even in a production build, will probably be a few hundred K of JavaScript downloaded. So if you can defer loading that JavaScript at any time in your application workflow, I suggest you do so for performance reasons. And with that, I'm going to go ahead and hand it off to Tom so he can go ahead and talk about using Esri Loader as another option for consuming the API. Can you get the best of multiple worlds here?
All right. Thanks, Renee. So as Renee just showed, ArcGIS Core is great. It excels at this sort of scenario that is common for modern web app development, where you are installing and then importing your dependencies. But there are times where you might not want to do that with the ArcGIS API, even in a modern web application. And the reason is the ArcGIS API is different than the average package that you're installing from NPM. It's a very powerful library with a very full featured set of capabilities, and that means it's got a large footprint. We mitigate this internally by making heavy use of dynamic imports for modules and also do some work with web workers so that your end users, they only get the JavaScript they need when they need it. But this all, when you take all this and you put it through a bundler, it can slow down your build. And even sometimes if you're working with build tools that have strong conventions or like these so-called no config build tools like Parcel, you might have to do a lot of extra work to try and get ArcGIS Core working in that scenario. So we do have a third way for you to get the API. It's called Esri Loader. And Esri Loader is a package that you can install from NPM. And what you get is a function called load modules. So you would import load modules in your code, and then when you want to use it, what you're doing is passing an array of ArcGIS module names. And once load modules has gotten those loaded, they become available to you, and then you can just write ArcGIS code the way you've seen in other examples here or in the documentation. Now, if you look at the signature for that function, it probably looks familiar, and that's because it looks just like the call to the and require function that Andy showed earlier. And this indeed is what load modules is doing under the hood. But it's doing a couple of other things. One of the most important things it's doing is it's going to lazy load the ArcGIS API for you. Renee showed this in his Webpack application and talked about how this is important for that initial load performance of your application, especially when the map is not necessarily the first thing you see. That's what Renee showed. But even if it is, this is just a best practice all around because it helps, especially for your mobile users, helps them have a good experience while they are waiting for the map to load. And the way Esri Loader does this is by the first time load modules is called, it's going to inject a script tag into the page. And that script tag by default is going to point to the latest version of an AMD build on Esri's CDN. So it's all starting to come together, you see. Now, you have options. You don't have to use that version. You can use another version. You can even use a 3x version if you need. And also, if your application is running in an environment where you don't have access to the CDN, you can point it to a local AMD build on your network. And you can even configure Esri Loader to lazy load the CSS. All of these things together are just, really syntactic sugar around working with the AMD modules in a way that makes sense in a modern web application, and with a couple of best practices built in, like lazy loading. And again, the reason we're doing this is it keeps the ArcGIS API code out of your build, which results in faster builds and greater tool compatibility. What's the catch? Well, first thing is you don't get that, you can't use import statements for your ArcGIS modules. And that may sound just like syntax, but at this point, I think most developers are used to using static imports and used to having all of their dependencies there and available to them. And there are certain workflows where it is inconvenient to have to try and wait for a module to load asynchronously before you use it. And then, of course, there's no code in Esri Loader itself. It's a very tiny library. It requires the existence of an AMD build to be hosted somewhere. Like we said, by default, it's going to point to the CDN. The CDN is always there for you, but if you're in one of those environments where you don't have access to the CDN, then you have to pull down our SDK and create an AMD build and host that locally in your own environment. Some people ask about, aren't we losing the benefits of tree shaking and modern builds where, at build time, your bundler goes through your app and picks out just the bits that you need, and out of this giant library, you're only going to get 200K. Well, that may be true. That would be true if the alternative wasn't an AMD build. I think most people are not familiar with AMD builds or don't realize that essentially the same thing is going to happen when you use the AMD build. The browser is only going to get the 200 KB that it needs. It's just instead of that happening at build time, it's going to happen at runtime. So, given these trade-offs, when to use Esri Loader? Well, anytime where build times are critically important. So if you're like you need to iterate rapidly, you're prototyping, you are in a hackathon, something like that. And then also in the rare scenario where you've got build tools that have either strong conventions or they're doing something really avant-garde or something unusual with dependencies, then Esri Loader is probably just gonna work, and ArcGIS Core might be something you have to wrestle with a little bit. So now we're going to take a look together at a couple of examples of each of these situations. So as a first scenario, let's say that I am in a hackathon and I've only got 24 hours to create the next killer web mapping application. I need to use tools that are going to keep me as productive as possible. These days, as far as a framework goes for this kind of situation, I'm liking Svelte. And I've heard, as far as a build tool goes, that Snowpack builds itself as the faster front-end bundler. So we can take a look at that. And we see here under the Getting Started, they've already got a Getting Started with Svelte, so that's going to be great. We can get up and running quickly with that. And finally, it didn't take me too long to find an example on GitHub of how to integrate the ArcGIS API into a Svelte application. And this one's even using Esri Loader, which is perfect. Let's see what this looks like by going to the live example here. So this appears to be a really simple example. You load a web map, and then as you move the map around, the lat and long of the center are updated underneath. This is great. This is everything we need to get going and up and running. So let's start hacking. So here we are in my project folder. I've already used Create Snowpack app with the Svelte template to scaffold out this Svelte application. And as we can see, the whole app is pretty much in this one app.svelte file. The only thing we need to do before we start working on this is to install Esri Loader. So I'll do that down here at the command line. And as soon as Esri Loader is installed, we can start the development server by running npm start. And there we go. This is the little default application that comes with the template. Not much to it, so let's get these side by side while we're working here. And I'm going to get rid of all of this default code, and we're going to be copying over the code from the Esri Svelte example repo that we already looked at. And fortunately for us, all that code is in a single function. So really all we need to do is just kind of drop in the HTML and CSS that we're going to need for this first before we copy that over. So we just got a div for the map and a placeholder for the center text, the lat long, some styles for the map so that we can see it. And then we've created this property called center text, and we're going to initialize it to loading, and then once the map loads, we'll update it with the lat and long, and that's how that example works. So let's go ahead and save this file, and you can see it's updated over here almost instantaneously. And so now we're ready to start making a map here. We're going to need to use load modules, so we're going to import load modules from Esri Loader. And then, like I said, that app, fortunately for us, that app had everything in a single function. So we're going to copy that function, paste that function over here. And the function's called create map. We'll break it down bit by bit. It takes in a DOM node, and it's going to call load modules and wait for it to load the map and map view classes. It's also configuring Esri Loader to lazy load the ArcGIS API, the CSS, so that we don't have to add a style tag. And then this code right here is just your standard boilerplate code for creating a map, creating a view. This is basically copy and pasted directly off of the sample pages. There's nothing specific to Esri Loader there. And then once the map's been created, we're going to watch the center and update that center text with the latitude and longitude. So let's, and in order to invoke that, once this has been rendered, we're just going to tell Svelte to use create map, and we'll hit save. And there we see the map was here. Everything's working just as we expected, and that build that included Esri Loader for the first time took just a couple of seconds, if that, and subsequent rebuilds will be even faster. So if we needed to hit this here, we'll just say we want to start at a different zoom level, hit save. You can see it's like instantaneous, and you can see how we'd be able to iterate quickly with these fast rebuilds thanks to these tools that are focused on that kind of speed. And the final example that I want to show you is that scenario where you're using some really cutting edge tools. I wanted to see how it would work out to bring the ArcGIS API into a WMR application. If you're not familiar with WMR, it is by the same people who created the Preact framework. And what WMR does is it scaffolds out a new Preact application with a router and everything you need to get going, but it is it's baking in a bunch of best practices, but it's also doing some really unusual things, one of which is that you don't have to install your dependencies. You just write an import statement and WMR somehow takes care of it. To be honest, I don't even understand how this works, but I wanted to see, I had this inkling, this feeling that it would just work with Esri Loader. So I created this WMR example application. You can find it under my GitHub. And the idea was I would just take the application that's scaffolded out by WMR and add this little map to the about page. The contrived idea being this was like a, contact us, come visit our headquarters, and the map shows the location of the headquarters with a point. And in order to do this, I actually used another library called Esri Loader Hooks, which you can also find under my GitHub repository. But Esri Loader Hooks provides some React hooks that you can use in any React or Preact application to write components that do things with the ArcGIS API. If you're not familiar with React hooks, that's the subject of a whole nother talk, but you can think of them as little helper functions. So in this case, we want a map and we want to add a point graphic. And so I was going to use the useMap and useGraphic functions that are provided by Esri Loader hooks. Now, what's crazy is all I had to do was type this code into the file of my map component I was adding to the project, and all of a sudden I was able to use all of Esri Loader hooks and all of Esri Loader, which is its dependency, without having to install either one of those packages. So here we have that application. We can see it in action. Again, this is just the default application that's spit out by WMR, the default Preact application. There's a little counter on the home page, and then there are these links to the different routes. On the About route, I was able to just drop in a map component here that adds that graphic to the map, and it just worked. We'll take a look at the code for that. So here's the entire code for that map component, and as I said, as soon as I typed that import statement, I was able to use Esri Loader and Esri Loader hooks without installing them. I'm not going to go break down the map component line by line. I know not everyone is a React developer. As we said, it creates a point graphic and creates a map and draws the point on the map. What's interesting about this is it's, less than 20 lines of code, fits on a single slide. I could copy and paste this and drop it into any WMR app, and it would just work over there. To be honest, even I was surprised that this, that Esri Loader just worked in this scenario a little bit. And if you're using tools like this, this is kind of the scenario where you would want to prefer Esri Loader. Maybe ArcGIS Core would work in this situation someday. We'll see if Renee is able to get it going. But in the meantime, you can count on Esri Loader to just work with whatever kind of tool that you're using. In conclusion, consuming the ArcGIS API is easier than ever. We've explored a couple of different options for you. I think that most devs are going to prefer that install and import workflow that's common to web apps. So I think most people will be using ArcGIS Core. However, if for some reason that doesn't work for you, for whatever reason, then Esri Loader and the underlying AMD modules are there and available to you to use in your applications as well. We want to thank you on behalf of Andy and Renee. I just want to thank you for spending some time with us today, and we would really appreciate it if you could take just a few extra moments to fill out the survey that is linked in the description below. This is the first time we've given this particular talk, so your feedback will really help us make sure that we've hit the mark and tell us where we could improve it for later iterations. So once again, thank you and enjoy coding with the ArcGIS API for JavaScript.
All right, awesome. Thank you for coming to our session today. Now we're going to go ahead and cover a few questions. So Andy, why don't you kick us off with the first question at the top here?
All right. So the first question is, when will ArcGIS Core be complete, essentially leave the beta phase? And that's going to happen at the 4.19 release, which is later this month. Once it comes out of beta, we'll update the SDK documentation and the samples on JS API resources at github.com/Esri. Those samples will also be updated. And I'll pass it back to you, Renee.
All right, awesome. So we have the next question here is, will AMD still be supported, or will you need to update our apps to use 4.19 plus in the API in the future, or will everything be backwards compatible with AMD? So I guess I can cover this one real quick. AMD is still supported in the API. We have two packages now in the CDN and NPM. We have the ESM build, and we have the AMD build. So if you want to continue using AMD, you still can. You don't have to migrate. And we're going to continue to provide the AMD packages and the AMD CDN in the future. So there's no requirement for you to move on. It's just we provide the ESM builds now to make things a bit easier for you to build your applications with. So like I said, in terms of backwards compatible, I mean, they're feature-wise, the AMD build and ESM build are exactly the same feature-wise. It's just how you're going to build your apps with them. That's the only difference. Next question we have here is, will we still need to do the copy asset step with upcoming ESM releases? We show in some samples how you can copy the assets from the node modules to your deployed build for your local builds. At 4.19, you will no longer be required to do that. So the default is going to be that you're going to use the assets from the CDN, whether you use the CDN version or use the local build version. So you do an npm install ArcGIS Core, the workers, the styles, the fonts, and all those other static assets will be loaded from the CDN by default. If you want to copy them locally, you can. And there are certain use cases you might want to do that, such as you're working inside of a sandboxed environment that's not going to have access to an outside network, then you have the option to do that, but it's not required anymore. So no, you no longer are required to do that with 4.19. Next question we have here, now that ES modules for the API are out of beta in 4.19, does it support full tree shaking experience with Webpack? So it currently does support tree shaking in the API completely. What you're probably seeing in the builds is a lot of bundles created when it does a build, whether you're using Webpack or Rollup or any other variety of build tools. And that's just because internal in the API, we do a lot of dynamic importing of modules. So we only load things as needed. So even though you have a handful of bundles in your application, you're only going to load a few of those resources at runtime. So even though your deployed build might contain like 12 megabytes of JavaScript or files, you're not going to load all that. You're only going to load maybe up to a megabyte or less for a 2D application and a little bit more for 3D. So it's just in terms of how the build is actually done itself. We're working on improving that with every release in terms of how we dynamically import files and making it so you don't load code you don't necessarily need. And that can happen with things like classes and stuff. And we're going to be working on that in every single release going forward. So does it currently support tree shaking? Yes. And we're going to improve that feature down the line as well. So next question here, will the slides be available for reference purposes? So I believe I put the link in here for this one. So if you look at the answer to this question, there's a link to the GitHub slides. So you can go ahead and view them on there as well. Okay, is destructuring preferred for individual imports like import map view from ArcGIS Core? So the ArcGIS Core root doesn't have
export of all the modules, so you wouldn't do it that way. Where you could use destructuring, though, is something like watch utils. So you do an import destructure when false once from ArcGIS core watch utils. You can do that. And that would be preferred for things like tree shaking, because you're only going to use the when false once method and not all the other watch utils helpers that are available. So you would use in the case like that. But for the way that this particular question is asked, we don't have a route in ArcGIS core that exports everything. So you would still need to go directly to the map, and as well as to the views, map view, and so on. So next question here. This one is, which of these JavaScript APIs, Backbone, React, and Angular, will go smooth with Esri maps rendering? What would be the recommendations? So I'll pass this one on to Tom. He can answer this one pretty good.
And the short answer is any of them. I mean, there's no, in terms of, well, between Renee and I, we've used them all with the ArcGIS API for JavaScript. At this point, you can, the reason we provide you so many ways to consume the API is so that you can choose a way that fits in with whatever framework you like, that makes it the easiest to get the API into that framework application. That's historically what's been the hard part. I mean, the question specifically mentions rendering. There's nothing at that, once we get to the stage of the map actually rendering things, the frameworks are not involved. So use the framework you want to use and just pick the method for consuming that makes it the easiest for you to get it into your framework.
Awesome. So there's another question here I'll cover real quick. Do you still need to use types ArcGIS JS API for using the core ESM modules? So those typings come from the definitely typed repo that we have for the 4x API. You do not need those if you're using the ES modules build of the API, because we already include the typings with the NPM build. We also include the typings with the AMD build of 4x as well. The real use case for using that particular typings package is if you're going to be using JavaScript, and you're going to be doing some trickery to load the CDN in to build your app. Then that's a case where you'd want to go ahead and use those typings so you have reference to them in your application if you're not using the packages directly. Let's come down the list here. Oh, this next one's for me as well. Do you need to do any configuration to use the ArcGIS API ES modules when using something like Create React App, where you can't modify the Webpack config? No, you do not, because the Webpack plugin that we provide will work with the ES modules, but it's not required. And the only thing it really does is copy the assets locally. And since you don't need to copy assets locally anymore, you don't even need our plugins. So you could just use the API directly and Create React App, and everything will just work. You don't have to modify the Webpack config or anything else like that for things to work, which is the beauty of using the ES modules today. They just work across the board. There's very little configuration, if any, needed at all to use them. So this one I'll give to Andy. Does it work with Angular CLI instead of Webpack?
The answer is Angular CLI comes with Webpack. And just to clarify that a little bit, since Angular 8, we're currently on Angular 11, and Angular 8, you're no longer able to eject Webpack, and you had to use the ArcGIS Webpack plugin that Renee was just talking about. With the release of the ArcGIS core modules, you don't need to use that plugin anymore. It's not required. And the modules, you can just npm install them, and it'll work directly with the Angular CLI.
So I'll pass this next question to Tom here. Is there a way to use Esri Loader on a 3x version of the JavaScript API?
The answer is yes. That's it. There's instructions in the Esri Loader repository README for how you configure it to point to the 3x version.
Awesome. So I'll pass this one on to Andy here. Are there any resources for using the API with Vue.js?
The answer is yes. If you go to github.com/Esri and search for the JS API-resource repo, that's where all our ES module samples are. There is a Vue.js sample there, and that sample will be updated at 4.19 to make the changes that we talked about in the presentation related to assets. So the answer is yes.
Awesome. So I have a question here I can answer. What sort of work should we expect to do if we set up a new app with ES modules now and then switch to 419 in May, assuming we're okay with the CDN modules for the assets? So what you could do today, if you did not want to copy the assets with 418, is you could go ahead and use ArcGIS core config. There's a property called assets path in there. And we actually show this in the JS API resources repo that I linked earlier in the questions. You could point the assets path to JS deliver for the assets themselves, and they will go ahead and load from there. So if you don't want to copy the assets today, you could use JS deliver to do that for you. And JS deliver works really well because it actually is going to load the NPM package, and everything is just going to work correctly in that particular case. So yes, you could use it today, and then the only thing you would do when you upgrade to 419 is you could remove that configuration that you did in the assets path. Just delete that line of code and you're good to go. Shouldn't be anything else you have to do at that point. See here. There's one more question I think we can answer really quick here. When writing and hosting a custom widget developed in TypeScript, which approach is best to load my custom widget? Currently, I'm using Dojo Loader pointing in my widget repo URL. So you could still go ahead and write your custom widget the way you're doing today. Just instead of using the Dojo Loader or anything related to Dojo, just use a build tool to go ahead and load it. So you don't have to write any special path configuration to say that this is where my widget's located or anything else like that. You can just go ahead and use Rollup or Webpack or any other tool of your choice that's going to go ahead and build your application for you. One thing to keep in mind if you're developing custom widgets using our widget framework that we outline in our guides, then when you do that, you want to make sure any build tool you use, is it going to do any overriding of your tsconfig stuff so that it tries to use React namespaces to create the VDOM. You want to make sure that everything's set up to use our stuff, and you can look at the guide for how that would work. So I mean, it looks like we've pretty much are done with questions here. If you have questions we weren't able to cover today, you can go to the Ask the Experts page and ask any questions there. And they'll usually get trickled down to someone that could help answer the question, and they'll respond back to you in the Ask the Experts page. So I think there's like a couple minutes left. Let's see here. Oh, here's a good one.
Question.
Yeah. What target JavaScript version of tsconfig works best with the new ESM modules? So you'll want to use, we build it out at, I think to 2019 for the JavaScript version, unless you're doing custom widgets right now. And unfortunately, we have to fix this in the API. I don't think it's fixed at 419 yet. If you're using custom widgets, then you have to target ES5. If you're not, and you're just doing a regular TypeScript app, you can go ahead and use 2019. You could use ESNext. Those will all work in the tsconfig using TypeScript. So that's something to keep in mind. Here's one. I think, Andy, you might be able to answer this Angular one here. If you use 418 Angular and set the routing so that it can reload any page using Esri config assets path equal a URL, otherwise the page won't get the assets folder. Is that something that you've seen come up before?
Yes, we've also seen where just depending on how you set up the assets, if you just use // and the folder name, depending on how your routing's configured. And also to put in a plug for all the Angular people on the line for this Q&A, tomorrow is an intermediate to advanced Angular session, and we'll be covering this in more detail there as well.
Great. There's one more question here. Does ES module include hover info, geometry query, and editing feature? So I think I mentioned this earlier, but feature-wise and capabilities-wise, the ES modules and the AMD modules are exactly the same. All the features between one and the other are all there. The only difference is how you're going to build and maybe even write your applications. Other than that, the features are identical across the board. What browsers? Okay, let me get this question in the queue. What browsers do the ES modules target when testing in January ran to syntax error and Edge? So The ES modules only work in modern browsers. We dropped support for IE11 and we've dropped support for Legacy Edge. What this did for us is it let us remove all of the shims and polyfills that we were using to support those old browsers. It also let us write our code a bit cleaner and remove extra stuff that we didn't need so that it'll work in things like Google Chrome and Chrome variants such as Edge and Brave browser, works in Firefox. It'll work in the latest Safari. Most of the latest Safari can do some weird things every now and then, but they all kind of do in various updates. Something could be a little odd every now and then. We do hit those cases, but usually they're fixed pretty quick, either by changing something we do on our end or either by a browser update once we submit an issue to the browser maker that something may have broken in that case. Okay, I think we are good here in this particular case. Oh, and I think I mentioned before the browsers that we target. Yeah, it's just we target JavaScript-wise 2019 for the build, which should be all the latest browsers. If you have the Babel RC, that would be browser targets, I think last one version or something like that. So that's something to keep in mind. But thank you very much. I appreciate it.